This is an image of the cosmic cliffs in the Carina Nebula as captured by the James Webb Space Telescope. It sits at about 7,600 light-years away from Earth. Resembling mountains and valleys dotted with sparkling stars, this is a region in our galactic neighborhood where new stars are born from the giant clouds of gas swirling in the intense ultraviolet radiation emitted by other extremely massive and hot young stars in the area. Star formation is essentially a giant recycling program. Clouds of gas and dust collapse into ball-shaped masses under the influence of gravity, and when the internal pressure and temperature get high enough, that allows for nuclear fusion. And so the star begins to shine. When it runs out of fuel, it will die. Depending on its mass, this can happen slowly or spectacularly, and a lot of the star's material gets ejected deep into space, where it can become part of new clouds of gas and dust, starting the whole process all over again. As a star forms, it also forms a protoplanetary disk, and eventually planets. And given time and perhaps a bit of luck, life could develop on a planet. To this day, it's absolutely not clear how life happens. We know that conditions on Earth were very different billions of years ago when life probably first started to develop. We know the essential building blocks for life are rather common in the universe and may have started to form as soon as 100 million years after the Big Bang itself. But to this day, the exact process of how life begins is still one of the biggest mysteries scientists are trying to solve. The life on our planet has been around for at least 4 billion years, and it has survived quite a few extinction events and always managed to bounce back. We also know life can adapt to extreme circumstances. While most life we know of requires sunlight, water, oxygen, and moderate temperatures, there are life forms that thrive in extremely cold, hot, dry, dark, or acidic environments. Bacteria have been found in radioactive environments, and microorganisms have been found living half a mile below the ice of Antarctica. Research has shown that microbes seem to be able to adapt to circumstances similar to those on the planet Mars, and that they may survive extreme gravity and even high-speed impacts. The bacteria Deinococcus radiodurans is known as a polyextremophile because it can survive cold, dehydration, vacuum, and acid, and has been listed as the world's toughest known bacterium in the Guinness Book of World Records. All of this makes it seem quite realistic that life, at least microscopic life, may be common in the universe, considering it can adapt to a wide array of circumstances. However, so far we don't have any evidence of life existing or ever having existed anywhere else except on our planet Earth. And so, if we want to answer the question this video poses, we can start by asking, how long could life last on Earth? Well, most likely life would first have to withstand a few more extinction events, such as meteor impacts, supervolcano eruptions, and heavy pollution and rapid climate change caused by human activity. Now, life is sturdy and adaptable, so even if any of these events wipe out most life forms and civilization as we know it, there's a reasonable chance it could still last for a very long time. At some point, about 1 billion years from now, life on Earth's surface will have to deal with a serious problem. The sun is ever so slowly getting hotter, and by this time it will have heated up so much that the oceans are quite literally boiling off the planet, and any life forms that have survived that now have to live underground, far away from the relentless rays of a swollen sun. It would be like watching evolution in reverse. Over the course of millions of years, countless of complex life forms will die out, and in the end, only microscopic life might still be hanging on, inside pockets of liquid water tucked away deep below the scorched surface. When the sun reaches the final stages of its life, it will swell up to 250 times its current size and swallow the inner planets Mercury and Venus, and most likely the Earth as well. And so that will be the end of life on our planet. The sun will then shed its outer layers and become a spectacular nebula, with its remaining core at the center, a new white dwarf star. In a much more optimistic scenario, our distant descendants, or perhaps even an entirely new intelligent civilization, will have colonized the rest of the solar system and can escape the increasingly intense heat of the sun, riding it out on a moon of Jupiter or Saturn, or colonies near Uranus or Neptune, Maybe they will even have figured out how to change the orbit of the Earth itself and move it out of the way of danger. For instance, by changing the trajectory of asteroids so they fly by Earth and push our planet in whichever direction desired. Or maybe they will have left the solar system altogether and found new homes orbiting younger stars, becoming galactic nomads of sorts, moving away as soon as a star system becomes uninhabitable. And so naturally we can ponder the question, how long could life last in the universe? That's assuming two things. Life on Earth will outgrow its home and settle elsewhere, and life has evolved on other worlds as well. In that last case, the story doesn't really change that much. If life on an exoplanet isn't completely wiped out by an extreme catastrophe, it will likely last as long as its home star shines. And maybe even longer. If a planet sits far away enough from its star so it doesn't get swallowed up during its red giant phase, life could possibly still keep going after that star becomes a white dwarf. And it doesn't even have to be a planet of a sun-like star. Planets have been discovered orbiting smaller and bigger stars, and even neutron stars, supernova remnants of stars many times more massive than our Sun. Now, these planets reside in extremely hostile environments, with high levels of ionizing radiation and high-energy stellar winds, so it would seem unlikely that life could develop in such places. And it's even less likely any life forms would survive a supernova explosion in the first place. But who knows? We are looking at the best case scenarios after all. Another interesting option is life on rogue planets. Rogue or free-floating, interstellar, nomad, orphan, sunless, starless, unbound, or wandering planets are, as all these names suggest, planets that don't orbit any star but are coursing freely through the cold depths of space. They may have gotten ejected from the planetary system in which they formed, or maybe they were never gravitationally bound to any star. There could potentially be trillions of rogue planets in the Milky Way alone. These wandering planets could have atmospheres and generate internal heat, and so liquid water could be present. It's not unthinkable life may develop on rogue planets, and possibly even intelligent civilizations. It's definitely interesting and quite mind-blowing to imagine an intelligent species that lives on a planet with no sun, the eternal night sky sprinkled with millions of distant stars. They might at some point discover that planets do orbit stars, and wonder if anyone lives on such planets, what the color of their sky could be, and what a sunrise might look like. Now, let's take a look at the future of the universe. And to understand the future, it helps to understand the past, so we're going to go back before we go forward. According to the Big Bang Theory, the commonly accepted theory on how our universe came into existence, space and time and everything that we know of started with a kind of explosion about 13.7 billion years ago. During the first second of the universe, the temperature dropped from a quadrillion degrees to only about 10 billion degrees, and the entire amount of protons and neutrons was formed from this primordial plasma. After 3 minutes, hydrogen, helium, and minor amounts of lighter elements started to form. This is also absolutely mind-blowing because hydrogen is the most common element in our bodies, and all these atoms are almost as old as the universe itself. They have been in other stars, in clouds of cosmic dust, in icy comets that crashed into the primitive Earth, providing it with water, so the first oceans could form. And from those shallow waters, the first life forms, and then in many billions upon billions of creatures. All the way to you, watching this video right now. For about 400,000 years after the Big Bang, the universe was this hot, dense, highly energetic soup of particles bouncing around and around, until the temperature had gone down enough that hydrogen gas could start to form. And for the next few 100 million years, the cosmos cooled down further and grew darker. But as we know, this darkness would not last. The massive clouds of gas started to pull together and become heavier and heavier, until the pressure and temperature in the core was so high that hydrogen molecules started to fuse into helium. And so the first stars were born, bathing the universe in their light. This first generation of stars were probably massive and short-lived, only a few million years, and their violent, extremely energetic deaths created most of the common elements we see today, and seeded the universe with them, so new stars, planets, and eventually life could exist. We live in an exciting era of our cosmos. There are still so many stars and galaxies to discover. We have found that there could be trillions of planets outside of our solar system, and that there could be other life forms out there. For every discovery we make, we find new questions and mysteries to solve. We have ventured away from our home planet and dream ever bigger. We could someday colonize other planets and moons in our neighborhood. We might settle worlds orbiting nearby stars. We could go as far as exploring the galaxy, or even beyond. And if we're lucky, someday we'll get to meet other intelligent beings. Of course, that all depends on whether humanity will survive long enough to do all of these things. We are currently facing the greatest challenges our species has ever had to deal with. We are very capable of wiping ourselves out completely, and so our future depends entirely on our willingness to rise above our selfishness, close-mindedness, and greed, and if we can free ourselves from the claws of our darkest tendencies. If everything goes right, humanity and its descendants could live for a very long time. Suppose we leave our solar system and colonize the galaxy, our civilization could potentially last for billions, if not trillions of years. Simply put, so long as we can find resources and energy, we should be good. And if it's not us, there's still the possibility of other intelligent species. In the end, we are all made of stardust. Maybe a couple of atoms that are a part of me or you, or any human or past or future life here on Earth could someday be a part of another thinking, dreaming, stargazing being. Billions of miles away, billions of years from now, long after our home has ceased to exist. In a way, that's a hopeful prospect. But life, whether it's microscopic or an intelligent, technologically advanced civilization, will run into trouble at some point in the future. It all depends on how the universe will end. There are a few scenarios that seem likely by our current understanding of physics, although there's a lot of uncertainty because that's just how trying to predict the future works. We don't have all the pieces of the puzzle, but we have enough that we can make an attempt at predicting the ultimate fate of the cosmos. Hypotheses on the end of all space and time include the Big Crunch, the Big Bounce, the Big Rip, the Big Slurp, yes really, and the Big Freeze. There's a stereotype of scientists being bad at naming things, but I think they nailed it with these ones. The Big Crunch hypothesis states that at some point the expansion of the universe will stop and reverse, and all matter will accelerate back towards a common center, and contract into an extremely hot, dense state. The Big Bounce hypothesis then suggests a brand new universe will quite literally bounce back into existence, in an infinite cycle of big crunches followed by big bangs. However, the Big Crunch scenario doesn't imply that a big bounce has to follow after. Modern research suggests that these hypotheses are not very likely, but they're still interesting to think about. Either way, if a big crunch is on its way, that's not good for any life anywhere in the universe. In case of the Big Rip, all matter in the universe, from stars to galaxies to atoms and subatomic particles, and even the fabric of space-time itself, would get pulled apart by the accelerating expansion of space. If the Big Rip scenario can happen, it could happen relatively soon, about 22.3 billion years from now. Okay, that is still a long time, but seeing as the universe is already 13.7 billion years old, a good chunk of its lifetime is already gone. For life in the universe, this is pretty bad news. It already took life on Earth about 4 billion years to evolve an intelligent species, so if it takes that long everywhere, that's not a whole lot of time left for many other civilizations to rise. Now, 22 billion years is a lot of time for any civilization to mature and develop highly advanced technology, provided they don't destroy themselves. In the best case, civilizations colonize their galaxies and can even travel to other galaxies. But when the end comes, they will powerlessly watch it creep closer and closer for millions of years. In the final months, star systems will become gravitationally unbound, and planets will fly off into the ever-expanding universe. In the final 30 minutes, everything from stars and planets to black holes will evaporate into atoms, until even they are pulled apart in the very last moment. Then the universe ends in an unusual kind of singularity, where all matter is infinitely spread out. Fortunately, current research and data suggests that a Big Rip scenario is probably unlikely as well. Another serious threat to the universe and all life in it is the Big Slurp. What a name, I love it. It's also known as false vacuum decay. Very simply put, according to quantum field theory, if our universe is in a false vacuum state, meaning the energy is low, but not low enough to be a true vacuum, it could at any given point decay into a true vacuum. What happens then is you have this bubble of true vacuumness that expands at the speed of light and swallows everything. The quantum fields that underpin everything we know of, forces, matter, particles, all of it would undergo a transition to a more stable form, and so everything that there is now gets destroyed and replaced. The good news is, since this bubble of ultimate destruction would be traveling at light speed, it can't technically destroy the entire universe. Galaxies located further than 13 billion light years from each other are moving away from each other faster than light speed, so the Big Slurp won't catch up with them. On the other hand, nobody can tell when and where false vacuum decay would begin, so it might already be on its way, and we would never see it coming. But ultimately, it seems that we are more likely headed towards a big freeze, also known as the heat death of the universe. The big freeze means that the universe continues to expand indefinitely, and so the energy density will decrease until all structures decompose to subatomic particles and photons. One consequence of this everlasting expansion is that at some point, about 150 billion years from now, other galaxies and clusters will no longer be visible from our own. The local group of galaxies is gravitationally bound, so over time they will all merge into one big galaxy, and it will float in endless darkness. All other matter will have disappeared beyond the cosmic light horizon. Light from other sources in the universe will be too far away to ever reach us. Light speed itself will be too slow for anything to be able to cross the immense emptiness between clusters forever. Any new intelligent civilizations won't know how beautiful the universe used to be. And so, the cosmos will slowly but surely grow darker and colder. The cosmic recycling program that I mentioned before is not perfect. Every time a star dies, it leaves behind a significant amount of its mass. Smaller stars become white dwarfs. Bigger stars go supernova and become neutron stars, or black holes. After an immensely long time, say about 100 trillion years from now, all the material needed to form new stars will be trapped in these stellar remnants, and a fraction of it in brown dwarfs, star-like bodies that never got heavy enough for nuclear fusion, and planetary systems. Since most stars in the universe are mid to low mass, most of the stellar remnants will be white dwarfs. There will still be a few red dwarfs left, but even these extremely long-lived stars that can shine for up to 1 trillion years will burn out. And so, star formation will end. By this time, the universe will have expanded by a factor of approximately 10 to the 2554. And yeah, that is a 10 with 2554 zeros. Whatever remains of the old clusters and galaxies will extinguish over the course of trillions of years. A quadrillion years into the future, close encounters of stellar remnants will cause most planets to be ejected from their systems and flung out into the depths of space. By this time, the sun will have cooled down to 5 Kelvin, now a black dwarf. And this is the fate of all white dwarfs. Given time, they too will die out and become cold, dark spheres in the nothingness. Collisions between brown dwarfs will occasionally create new red dwarfs, for a time, and about 100 stars will still be shining in what once was our Milky Way. Every now and then, stellar remains will collide and the last supernova will light up, bright, lonely beacons in an ocean of the deepest black. 100 quintillion years from now, what's left of clusters and galaxies will start to disintegrate, and some of the remaining mass will fall into the supermassive black holes that were once at the center of the galaxies. Eventually, all matter will decay, and all that will be left are black holes, and then even they will slowly evaporate, until a googol years from now, all matter has fallen apart, and all that's left is just subatomic particles forever floating in the endless darkness. All there will be is infinite nothing. Now, like I said, predicting the future always comes with a lot of uncertainties, and the further we want to look, the blurrier it all becomes. And there are still many mysteries physicists and cosmologists are trying to solve. For instance, the influence dark matter and dark energy have on our universe, and whether protons will decay or not. We don't even know if black holes can evaporate. It's been hypothesized and scientists are trying to solve these questions, but so far we have no idea. And so the true end of the cosmos remains a mystery. And so does the answer to the question, how long could life last? It seems improbable, but it's possible life on Earth is all there is, and that at most it will last until the sun gets too hot. And if life develops elsewhere on any of the many trillions of planets in the universe, it might face the same fate. There could be other technologically advanced civilizations, but maybe they will die out or self-destruct before they can explore their galaxy. The stars will not shine forever, so life might cling to the last sources of light and warmth for a few trillion years. But eventually it will be snuffed out completely. In the best case scenario, humans become a spacefaring race and colonize the galaxy or perhaps beyond. We could harness the energy of the stars themselves and last until they all die. We could then upload our society to an extremely advanced computer, running on whatever tiny amount of energy that radiates from stellar remains like dying white dwarfs or even black holes. In a future so distant, time itself becomes meaningless. Obviously, all of that is highly speculative and well within the realm of science fiction. With the information available to us right now, life on Earth will last about 2.8 billion years at most. We are not doing well in dealing with serious problems that threaten our very existence, and we caused them ourselves. We appear to be racing towards the end of a cliff, and it feels ironic that we dream of a future of humanity as galactic explorers, while we seem so busy digging our own grave. But we might prove to be every bit of persistent and intelligent as we believe we are, and figure it all out, and fulfill all these dreams and forge new beginnings out of the ashes of our failures. Whichever end we will witness, we did spend our time stargazing and attempting to answer life's greatest mysteries, and solve the greatest problems we've ever faced. If we just keep doing that, we'll probably be alright, at least for some time. If life anywhere in space and time is as resilient as it seems to be here on Earth, it might just outlast every possible catastrophe it faces. And who knows, someday someone could find a way to leave our universe altogether and escape its seemingly inevitable end. For now, making a better tomorrow here on Earth is our best chance at making all tomorrows happen. Thank you for watching, and I hope to see you soon.